Mechanics vector approach problems. The problem number 1, it goes like this. A tower guy wire is anchored by means of a bolt at A as shown in figure 1. The problem is illustrated in this figure, wherein A is at a distance of 40 mm along the x-axis, and from the z-axis it is minus 30 mm, and B is at a point height from the origin 80 meter. So guy wire is anchored from A to B. We are supposed to find out the force vector FAB. The tension in the wire is given as 2500 Newton. We have to determine the component forces Fx, Fy, Fz acting on the bolt at A, as well as the angles theta x, theta y and theta z defining the direction of the force. We will see the basics first, then we will solve the problem. We have to get the answer. Fx as minus 1060 Newton, Fy as 2120 Newton, Fz 795 Newton, and the directions theta x as 115.087 degree, theta y 32.005 degree, theta z as 71.457 degree. We will see the basic formula. We know how to express a force vector in terms of distance vector. Here we have to calculate the tension vector AB. The formula is very simple. We have to take the tension component TAB multiplied by the respective unit vector lambda AB. It is further simplified as tension AB. The unit vector is expressed as distance vector AB by magnitude AB vector. Further, this can be written as TAB multiplied by OB vector. It's a simple vector formula for AB vector as OB vector minus OA vector, the magnitude as OB vector minus OA vector. This is the basic involved in solving this problem. We are supposed to find out the unit vector lambda AB. For that we need AB vector by magnitude AB vector. To start with, we have to identify the coordinates of this A and B. So the coordinates are A, based on the reference axis, we have this as x-axis, and here from the origin this can be treated as z-axis. So you have OX, this as OZ, then this as OY. So unit vector along this OX is I vector, unit vector along OZ is K vector, unit vector along OY is J vector. This is an obvious basic formula. Now we will see A. The point A is 40 mm along the x-axis. So the distance for x is 40, and it is on the ground. It is on the zx plane. So therefore no y value, 0. As far as z value is concerned, the value that is in front of this origin is treated as plus, and the one which is behind is treated as minus. So here we have minus, so therefore it is minus 30. The values are in meter. We go for the point B. Here when we take point B, it is on the y-axis, so it has only y value. Both x value and z value are 0. So therefore we very easily take the point as 0, and it goes above, so it is positive y-axis. So therefore 80 positive plus, and z is 0, so therefore it is 0, 80, 0 meter. Now we can find out the lambda AB very easily. So lambda AB vector goes like this. OB vector minus OA vector divided by magnitude OB vector minus OA vector. So corresponding to A, the position vector OA can be very easily written as OA vector is equal to 40I plus 0J minus 30K. Here is OB, so So OB vector is nothing but 0i 80j plus 0k. So here is your lambda AB, OB minus OA. So OB minus OA is 0i vector plus 80j vector plus 0k vector together minus then OA vector, that is 40i plus 0j minus 30k divided by this magnitude, OB vector minus OA vector. So this is nothing but minus 0 minus 40 I vector, here is 0, here is 40 minus, so 0 minus 40 I vector plus 80 minus 0 j vector plus 0 minus minus 30 k vector. So minus and minus become plus. So divided by this magnitude value is nothing but square root of 40 square plus 80 square plus 30 square. So we take this value with the help of a calculator, we can calculate. Ultimately this value comes to be minus 40i, lambda AB vector is minus 40i plus 80j plus 30k divided by this value can be very easily calculated. So it's square root of 40 square plus 80 square plus 30 square comes to be 94.339. So here is the unit vector lambda AB. B vector is nothing but minus 40i plus 80j plus 30k divided by 94.339. We know that TAB is equal to TAB multiplied by lambda AB. Given TAB as 2500 Newton, that is the tension in the wire along AB is given as 2500 Newton. So therefore this tension AB vector can be very easily find out with the help of this 2500 Newton multiplied by the unit vector along AB, that is minus 40i plus 80j plus 30k divided by 94.339. So this implies a simple calculation would do, that is TAB vector is equal to the first value is nothing but 2500 is the force value multiplied by 40 divided by 94.339. So this is the value which is 1060.006. The sense is negative, so therefore we can write this as 1060.006 Newton I vector. Then the second part is 2500, the first tension value, then the unit vector value is 80 80 divided by the denominator value is 94.339. So together we get 2120.013 plus. So this is 2120.013 Newton J vector plus. The last value is 2500 multiplied by 30 divided by 94.339, that's equal to 795.005. It is 795.005 Newton K vector. We very well know